Hello again. In this section, we're going to talk about expected value or expectation, sometimes you'll call it. It almost is going to feel to you like it's application problems for the probability distributions that we just finished studying. Okay, so when you hear something called expectation or expected value, okay, we're going to just think of that as the theoretical average of the variable. Theoretical average of the variable. Okay, so it follows that we have a formula that looks exactly like the mean of the probability distribution, because that's exactly what it is. Okay, so you'll be happy to know you already know the formula. We're just going to put it into an application. Okay, so again, in case you need interpretation, we're doing the sum of the x's times the p of x. Okay, whatever that is going to be your mean. And that was a p of x right there. All right, so let's set a couple of these up and see how this works. Okay, so 1,000 tickets are sold at $1 each for a color TV valued at $350. What is the expected value of the gain if a person purchases a ticket? Okay, so that of the gain is going to be important to us. All right, so what do we know? Well, we could be lucky and win the TV. If not, we lose. Okay, so it's either a win or a lose. Now, think about what do you gain if you are the winner of that TV? Well, you want to say, oh, maybe you just win a TV. Okay, well, tell me in terms of money. Okay, well, you might first want to say $350. Okay, but think about it. What did it cost you to play? Oh yeah, you had to pay $1 to get in. So truly, your gain, right, is $349 or $49. $349. What's the chance you're a winner? Well, 1 out of 1,000, because there's only one prize. All right, so if you don't get the TV, well, sorry, then you lose. You are just gonna lose your $1. Okay. Chance of that happening, 999 out of 1,000. Okay, so then you're going to calculate your expected value like we did the mean for probability distributions. You're going to multiply your x times your p of x, so 349 times 1 out of 1,000 plus -1 times 999 out of 1,000. Okay. And then you can load that in your calculator or come back through here. I'm finding that you're going to lose 65 cents on every $1 ticket that you buy. Or you could say something like this 65 is the average of the losses for each of the 1,000 ticket holders. So those people that buy a ticket can expect to lose 65 cents out of every $1 that they buy a ticket with over time. Okay, let's take a look at a second one. A ski resort loses $70,000 per season when it does not snow much and makes $250,000 profit when it does snow. The probability of it snowing at least 75 inches is 40%. You would call that a good season. Find the expected value or expectation for profit. All right, well, let's take a look here. So our ski resort is going to either gain money or they're going to have a loss. Okay, and honestly, when I made up this example, there were lots more zeros on this profit and loss thing. I just made it more manageable for us to calculate, because truly a business better have a lot more money coming in than this. Okay, so if it's a good season, our ski resort's going to gain $250,000. Okay. When does that happen? Well, if it snows, right? So 40% chance that it snows, so we'll put that p of x in there as 0.40 or just 0.4. If it doesn't snow, we're going to lose 70,000. So we'll put that in as a negative 70,000. The chance of that happening, well, let's think about that. If 40% is good, then 60% is a bad year, remembering that the P of X's have to add up to be 1. All right, so the expected value for our ski resort, we're going to take 250,000 times 0.4 plus negative 70,000 times 0.6. Okay, and that's a negative sign on there. So if you do the arithmetic on this one, you come out with a gain or the expected profit. That was a good one. Let's just put those two words right together. Make a new word out of it. All right. So we'll just say that that is the expected profit if this happened in a number of years. So again, that's not realistic if we added a lot of zeros on that, but I think you get the general idea. Okay, third example here. Let's go with, go back to our blue here. A coin is tossed. If the coin turns up heads, you win $10. So heads, you win 10. If the coin turns up tails, you lose 10. What is the expected value of the game? All right, so our X's, we could call this heads, tails. Heads or tails. All right, so what happens? If you win, if it's heads, you win $10. If it's tails, you lose $10. So we'll call that negative 10. So what's the chance on a coin that you come up with heads? You're right, 1/2 or do 0.5. Same for tails. Okay, so then if we want to do the expected value, you're going to do expected value 10 times 1/2 plus negative 10 times 1/2. Well, lo and behold, that's 5 and negative 5. That comes out to be 0. Okay, so this has a special meaning. If you get an expected value of 0, you call this a fair game. So if I ask you, is your game fair? This is how you know. The expected value is 0, meaning that no one is favored, is what I mean by that. Okay, no one is favored. Okay, all right, let's do one more example here. Okay, it says 1,000 raffle tickets are sold for $1 each. 4 prizes are awarded. If you purchase a ticket, what is your expected gain? All right, so we've got 4 and we're sold here. Let's pick out what we got. We got 1,000 tickets for $1, and then we have these 4 prizes. Okay, so let's set this up here. We can make a little chart here. So again, we're talking about gain. So if you're the winner of the $200 prize, what is your gain? And remember, you paid $1 to play. So if you're saying $1.99, you are correct. If you're the winner of the $150, what did you really gain? Yep, $149. If you are the $100 winner, you really gain $99. If you're the $50 winner, you gain $49. Okay. However, if you don't get one of those prizes, sorry, you're losing your $1. Okay. So then what's the chance of you winning? Well, there's one of each of these prizes out of the 1,000 tickets. So we'll do 1 out of 1,000 for each. Okay, then remember, all the rest have to be losers. We have to add up to 1,000 tickets. So that's going to give you 996 over 1,000. Okay, so then if I work this out, you're going to do 199 times 1 out of 1,000. 149 times 1 over 1,000 plus, I'm running out of room here, 99 times 1 out of 1,000 plus 49 times 1 out of 1,000 plus negative 1 times 996 out of 1,000. Holy moly, I should have written it on down the paper, I guess. Expected value, if you put all that handy dandy in the calculator, is that you lose 50 cents. Okay, so that just means that in average loss of 50 cents happens for every ticket. And if I say, is this a fair game? You would say, no, game is not fair. Okay, because remember again, you have to have an expected value of 0 for a game to be fair. Okay, so there you go. There's some applications of probability distributions, and this is called expected value or expectation. Thank you very much for watching. See y'all.